Hey everybody, I'm Nafil from JetBrains, and welcome to this webinar organized by JetBrains about building search for functionality with Python, Flask, and Elasticsearch. Elasticsearch is a product close to my heart. I've used it on many occasions. I've used Kibana on many occasions, so I thought it would be really cool to have somebody like Aravind join us today. Aravind is the developer advocate for Elasticsearch, and he's going to join us today and tell us about how we can integrate search functionality into our Flask applications. So without much further ado, Aravind, you have the floor. And before anybody asks, yes, this is being recorded.
Thank you, Nafil, and the JetBrains team. I'm indeed, really happy to kind of do this session. So before, I start on the session, I guess I believe you can see my screen, right, Nafil? It's on. Yes. Right. So please ask as many as questions. We'll take enough pauses to answer all your questions. In this session, I'm going to talk more about various things. Not so much slide, but I'll give you as much as information. I'll give you a GitHub repo as well. I'll also say share enough resources so that you can go back and build this by yourself. So let's get into it without further ado. So I'm Aravind. I work at Elastic as a developer advocate. I also run a simple newsletter related to tech and all. I've been running it like for last 3 months or so, and then I try to share more whatever I learned, everything related to technology, etc. So that being said, the agenda for the session today is we'll do a simple introduction to Elastic Stack for those people who are probably not really aware of Elastic and the entire ecosystem of what Elastic is, etc. And then we'll also talk about a bit of search, and then we'll explain about how to build search experiences with Elastic. If you are not specifically from Python language background, and then you still want to build search, I'll try to showcase some details that you could also use with Python as a backend, something like a Flask, and then you could use some sort of a React front ends, etc. So we'll see if we could cover that, and then we'll do a very longish demo. So I hope that I could complete everything and show you everything, and if possible, also integrate some of those logs, etc. And then share you a resources file so that you could go back and do it. But that being said, there are some expectations that I want to set. I know that it is extremely difficult to complete everything, but then I want to share some things that before I start this the presentation. And everything I show here is free and cloud agnostic. That means you could download it and run it self-hosted, as well as you could run it on any cloud. It's cloud agnostic. And then I will not be able to cover everything in the APIs or everything, but please ask as many as questions. I'll try to answer them. For example, we'll not be able to cover, there are so many aggregations, and then we'll not be able to cover, but I'll talk about it and show you if possible. And then we also have mapping related stuff, and there are more different types of fields in Elasticsearch now, like runtime fields, different search related fields like suggesters and all. That is another 45 minutes discussion. Then scroll ILM is, those are interesting concepts as well. I might not be following the best production practices like storing passwords in a secret store when it comes to sending logs and all. So please don't use this demo as is, just some sort of advice there. But that being said, I could share some best practices when it comes to Elastic. Please feel free to ask questions again. So that being said, let us get into the information about Elastic Stack and everything. So Elastic is a free and open product. You could download it. It's a distributed NoSQL REST-based data store, which is popularly used for search and analytics. Elasticsearch is the heart and soul of this entire stack that you are seeing. Say Elasticsearch is the core part of it, and then you have Kibana, which is a UI part on top of Elasticsearch, and then Kibana helps you to interact with Elasticsearch. It works sometimes like an administrative console, but it also does more. which I'm going to talk about in a minute. And then you also have beats and log stash, which are like a data ingestion modules. So beat helps you to there are multiple beats like file beat, metric beat, audit beat, which helps you to ship the operational data into Elasticsearch. Another part is like the log stash, wherein you have it's like an ETL tool which helps you to pull data from various sources and try to ingest data into Elasticsearch. So each one of them has different functionalities. All of them are free products that you could download and use it. So that forms the Elastic stack. But over a period of time, people started to use Elastic or mold Elastic into a few shapes. Like obviously, it started with a search focus. So that's how the search was born. And then like you also have people using from the DevOps community or the practitioner community using it for observability or monitoring use cases, where they could ingest logs, metrics, traces, uptime, synthetics. Now there are more things now happening on that side. And then now the latest fad, I mean, I guess like a lot many security practitioners or people are using it for threat hunting, which eventually led into SIEM. So now that being said, whatever the apps that you're seeing, the icons that you're seeing here, here, and here, these are Kibana apps that are embedded into the Kibana. These are again not per se paid or something, like you could go and use it, the product, whatever I'm trying to tell. So today we're going to talk about Elasticsearch by default and how powerful is it, and like the clients, etc., that you could use. And then we'll also see if we could how do you probably leverage one of the enterprise search feature. So again, I want to keep stressing this fact that when I say enterprise search, it's not for enterprises. It's also like free product that named as enterprise, because there are another things that are coming. So in lack of a better name, probably. That being said, you could also run this on Kubernetes. There is an operator. You could also run whatever I'm trying to show as a cluster or something as an operator. I'm trying to run everything in the cloud just to save my laptop, because I'm anyway gonna run my IDE, as well as I'm gonna run the Flask app, and also I'm gonna do some computation. I mean, I'm gonna build a Docker container. So I'm just trying to be like safe and putting that in a different place. You could spin up, download Elasticsearch, and then do all of that from a different place. Now, I hope you have got about Elastic Stack and etc. But then if you have questions related, please drop in at this point of time. I'll definitely take in a minute if there are any questions related to Elastic, etc. Now that being said, a lot many people ask I don't think search is so important, building applications, or probably thinking about I have a database, I would probably use a search. I run a select star query, but then even I used to feel several years back, and I used to feel the same, and I used to think about search, yeah, okay. But then I started to think, when I got a feature, and then I had to implement multiple requests that are very user facing, and it has a lot of interesting details. Then I started to look at various search experiences, and these are some that I collected. Probably some of them are regional apps, but then some of them you might know. These are something like food delivery that needs search functionality, or even popular apps like GitHub as well. And you inadvertently and without thinking, you would simply go and type the details, but it is a search that is trying to serve results, or search that is trying to suggest you something. I also realized that when you go to e-commerce search, you won't buy anything without searching. You would try to search, compare, and do a lot of things, which internally try to go and fire a search query on some data store, or a catalog of products that they have an inventory in their words, and then find out information about that. So that is one way to look at. And at the same point of time, I also figured out that uh, we search on every other places, even when we are doing development. Like say for example, on PyPy, you go to pypy.org, and then you type for say some package that you want to install, and then you go through filters and find out. Or if you go to dev.to, you are trying to search again, things or that way, and then obviously Stack Overflow. So all of these are search experiences, and it needs something that understands that full textiness and then gives you results in a proper format. So that's where the search or the search engines come into play. And obviously not everything can be done by Google. even though they do have a search specific product, which is like Google site search or something, or Google enterprise search. They have some suite of products which used to do that, which also has a powered by Google logo. But then if you want to build more customizations, and if you are an e-commerce company, even like Shopify, like you might want to build search yourself. So that's why the search is omnipresent, quintessential, and a lot of things came into picture. But how do you build? Obviously there are many options. I think there are many libraries, there are many things that you could go very specialized, and then choose a library. But a lot many people have been using Elasticsearch, and a lot of experiences that you probably are touching today are powered by Elasticsearch. And then it is so powerful that you could also run scripted queries. You could do calculations like GMV and all. Like if you are from e-commerce background, again, you could do all of that on Elasticsearch. And over a period of time, there are more and more search related features that are used to do other things for like say observability or security, which helped in other communities as well, not just the search community or the search people who are building search. So like I said, Elasticsearch is one such product. But there is another tangent that I also want to talk about at this point of time is, say Elasticsearch is really powerful, and then we are also I'm talking about for quite some time about Elasticsearch, but it's also very raw in nature. It's like a clay that you could mold in your own shape. And then you need to learn how to tune your relevancies. You need to learn to do many things which are very specific to Elasticsearch. And you might need to write queries which are a bit harder, so for some people, and it might be difficult for developers to spend more time. And that is one another thing. So over a period of time, folks who are using Elasticsearch from the community keep asking, like, how can you do this better, or can I write a plugin to make this easier? Like, say, how do I do query suggestions automatically? How do I deploy a machine learning model to learn what people are searching and suggest better? So there are many things that people want to do on top of Elasticsearch. And then over a period of time, we also have another solution, which is a layer on top of Elasticsearch, which is also free. And it's called App Search. What it does is, like, it builds simple, easier search experiences. Today we're going to go and see about both of them. There's an advantage in the App Search as well, like, which I'll show rather than talk about it more. So that being said, I think I'll just start showing the demo and other pieces, and then we can come back to the slides again and talk more about it later. So I already have a cloud cluster I have deployed. In the interest of time, I'm going to do a lot of things in the interest of time today. But that being said, if you have questions, please keep them coming and I'll try to answer. So I have this deployment which has Elasticsearch, Kibana, something called APM Fleet, and Enterprise Search. So just forget about them, but then we'll focus on Kibana, etc. So I also think that this has logged out. So let me log in. So if you are building an Elasticsearch cluster, make sure that you always turn on the security, which is also free. So make sure that you do that and secure your data, everything. It also has RBAC, and also make sure that you protect that. So I believe that quite a few people might know Elasticsearch, but then I'm also going to give you a simple sample that helps you to get started, etc. So when you come to the Kibana page, so this is Kibana, and then when you come to Kibana, you could go to Dev Tools, and you could either go to the left menu and find that out. But because there are more things now, like you could see there are more apps, and if you could search as well, and then it brings to this place, which is you could execute the APIs. Like I said, Elasticsearch is a REST-based API search engine, and then you could execute. So I would just see, if I want to run some query, how health of the cluster, and I could simply go and run this query, and then it would show me the details. So this is just like a console where you could uh, run the information APIs and then get details. That is one way to look at. And you could also find out what version of the cluster that I'm running by running these APIs. These are very common, and if you have used Elasticsearch, this should be a common thing for you. And then on top of it, Elasticsearch stores everything in indices. So today we are going to create an index using the Python client, REST client, and then we try to ingest data through the Python app, and then we try to search on top of that. And we also try to use another client that is more easier for you to use. So say for example, if I want to see what are the indices, like I don't want to create an index, but then I want to show you some indices, like which are there are so many, I think there are so many system indices which got created. And then like there are, for example, an index like apm profile 001. This just like your table in your database, but remember, it is not a relational database, it's a NoSQL database. So, and it has a schema. Elasticsearch is not a schema less engine, it's a schema free uh, data store. You could ingest anything, it'll sniff out or figure out what is the right data type for the data that you're trying to ingest. But that being said, I would not recommend you to do that. I would recommend you to create a schema and figure out what is what and tell the engine what is what, so that your search queries will be much faster rather than Elasticsearch guessing what it is. So how do I
Arvind,
send?
would you
Yeah.
would you mind just zooming in the web page a little bit because the text is a little small?
Okay, I'm sorry that. Thank you so much for
No
doing that.
worries.
I think 18 should work, uh, or should
Yeah,
I
that's fine.
make? That's fine. Okay, great. So I think I just ran the cat health API and also like I took a sample index that is already there and trying to show the mappings here. Nothing much. So I'm just trying to explain like how the data is ingested, if it got ingested, and what are the how the fields are assumed and what are the data types that are created. So in this session, I'm not going to go deep dive into mapping, how to do mapping, etc. But then I'm gonna show you this so that you don't like operate in the blind that oh, I don't need to do that. So it's very important that you create a mapping that works and for better, and then that is solvable. So in traditional Elasticsearch, go download or do homebrew, or like install via homebrew or something on your Mac, and then like you just need to like create an index, start ingesting data. But if you are building for production experiences, like make sure that whatever the document that you're ingesting, the JSON document, make sure that it is properly mapped, like so a text as a text, a number as a number, and a long as a long. I believe that a lot many people think like, why Arvind is saying this, but there are a lot of folks who miss this step and just use Elasticsearch as is, but it might not give you the best search results. And later point of time when you have ingested some, say, a terabyte of data, and then it might become difficult for you to redo all of that. So because you need to reindex the data, so that's another discussion to have. So that is something that I want to talk about. So like I said, this is Kibana, and then we'll come back to Kibana again. So I have, before I switch to the code, I have this entire code here in this particular repo. I have like 6 branches that we'll go through step by step. I and if you have doubts, and like this is the place where you could download all of this, the software that I'm talking about, and look into things. So let me now share my PyCharm screen.
Before you go
Great.
in there, Arvind, I just think people really need to appreciate Elastic for what it is because it's not just a database. It really gives you a really intricate level of control over what you're searching for. So what is the distance? How much fuzziness is there? So it's a very powerful way to query your data, but it's also kind of a Swiss Army knife, right? Like you can use it for a wide range of things, not just for search, but you can also put your logs into it and it can handle huge amounts of data.
Yeah. So Elasticsearch is quite powerful that way, and most of the time, like folks generally might not realize that it is so powerful. And then the simplicity of the software, to be honest, might get you started with production deployments quite easily. I believe that it's not. You also need to prepare bootstrap it for the production environments as well. So that's just my suggestion. So I guess if you could put my screen, I believe that you could go ahead. So I think this is visible. If it is not, if you can, you make it okay. Make my screen full screen. Like if you fully put me on full screen, only the pie chart, maybe that would be better. Oh, did I lose you, Nafias?
No, you're still here. Yeah, we can see everything. You might just want to make the font size a little bit bigger. That's all.
Yeah, that I'll do. But I'm thinking that if you could make, say, like, remove me from the screen and, like, make it
Oh, okay.
much better, that would be better. I mean, that would still be better. So I'm just trying to make it as big as possible, but then, it's still, it looks probably ugly if I really make.
There we go.
Okay. So I have, like I said, I have this GitHub branch, and then I'm going to start very basic in the Flask. And I really like the framework. It's simple. It gets me started very quickly. So I have the node modules, and which is not of interest at this point of time. We'll talk about in the next step. But I have the main.py, which is nothing but I have a simple template, and then I have Flask as my requirement, and then the index.html which says hello PyCharm. So let me quickly start this one, and then I believe I can't show you. Okay, that's great. So let me share my window. That's really, so I think I need to share my screen. Okay, so I believe you could see my screen. Let me go back, and then so as you could see, like, we just saw the PyCharm world. So we just did a simple Flask app, and it has a one single API to go through, and then that's it. So now let us kind of like go a bit more deeper, and then like add move to other branch, and then add Tailwind CSS. Now, why I chose Tailwind? I might not be able to completely explain Tailwind and everything, but then what I want to do here is try to explain a bit, and then come up. So basically, Tailwind is a declarative utility class based CSS framework. I used to use a different CSS framework previously, and I used to do a lot of like back and forth, and also it has effect on my like, the total app size, etc. And then with Tailwind, I found it very easy, and it was really good. So what I did is, like, I did npm init, and then I initialized the repository, and then I added three specific dependencies: Tailwind CSS, auto prefixer, which is specifically for different browsers, and then post CSS, Perl CSS, which is used for kind of like optimizing your application for production. So what I did is, like, I added. Okay, I'm sorry, I that also added a command, like in the script. Like, so say if I ask build css, it will go through my css and generate the a specific css file. So why does it need to do? Because Tailwind follows this directive based approach, where I have a base, components, and utilities, etc. And then this could generate a css file based on what I use here. So right now I don't have anything, and I just want to generate everything to get started, and then we could potentially optimize it later. So what I'll do is, like, I'll open my terminal here, and it's already in the same thing, and you see that I have already run that command previously. And what it does is, like, it would generate a css file at the main min. So I just run that again, and it will generate a massive file of 6 MB, I believe, and use it with, and put every css class. So like, it will be done in a minute. Not so in a minute, but then like maybe 10 seconds or so it should be happening. So with that, we would get access to like, a lot of utility classes that helps you to, like, write fantastic UI experiences. So that's why I was using. So I have included css main min css. So if you go here and go through static, I believe it should come, or else if I have to reload from the disk. Yes. So you could see that it is main underscore min dot css, and I have that included. And then just add class is equal to, and say I would use blue, but then wait, I think I am using this as at the wrong place. I should use it at the body level, so that my entire screen will become blue. So it's the same page, but then I'm just adding a class, so that to show you, that's it, nothing more than that. So I'll just stop the app and restart it. Mm.
I hope that the CSS changes get reflected. If not, what happens is I could like potentially I need to clear off my, yeah, it reflected. You also see that I added a different sort of like, flair to it, and then it changed differently, like the same thing, but it looks really different now. So you could use Tailwind to create fantastic experiences. So I have created a search page in the same index.html, and you could go and take a look at that. Now let me move to a different brand. So this is what I did, and then if you want to understand more about how do you optimize, because like for example, this particular file is say massive, like it is I think like more than 6 MB, or like 4 MB. I think it contains all the files, all the hit CSS classes. You could avoid doing that. What you could do is like you could still keep only bgblue class, because that's the only class that you're using, and generate a style sheet for it. So what I did is like that's why I installed post css, which helps me to like go through the html files like as it shows here, and it removes all the other content that is css classes that is not required. So if I run the, like say, npm build css, it might process a bit faster as well. So because I'll remove all the unneeded classes, and I'll only generate a simple minimum CSS file that is needed for my app. But also I could use the full list of utility classes to develop my entire application. Like you could see, it should be simple. Like I only have very few, not, and the file size also has reduced. So this is a good way to like start building more of UI experiences. Of course, like as much as we build backend apps, we also need something that is looking good, right? So that's why I use that. So I have a basic app, I have my UI layer added on it. So let me quickly go back to kind of like switch to a different repository. So I now in this repository we'll spend some time, because we are adding Elasticsearch, and let me move to that. So and then I'll talk more about the entire structure again. So large part of it I'm going to talk about this window, and like also main.py. So basically Elasticsearch is a server that is sitting somewhere, and you are writing an application that is in your IDE, and then you deploy it probably on a cloud service, and then that interacts with your data store, which is sitting somewhere, like be it on some VM, or like your own data center, etc. So to interact with that, you need to talk to the APIs, which I showed previously in the Kibana console, like be it cat indices, or ingesting data, creating these tables like indices, or mapping, etc. Everything, right? So we have a Python client that is available. Like it's also open source, and then you could go and literally contribute to that. Uh, so I would recommend, if you have uh, github.com/elastic/Elasticsearch Py. Okay, so the library is like is there, the code is here, and like it has all the it implements all the APIs. It also has some compatibility related information that you definitely need to know. So if you are looking at, say, for example, older version of Elasticsearch servers, then you might need to use a different sort of a client. So what I'm trying to use is the latest version here, and I also have the server which is a 7.14. So the Elasticsearch cluster is 7.14, and also I am using the latest client. So you could, and everything is on pip, and you could do pip install, and then you would be able to get it. So that is one thing. So now what I did here is like I just imported Elasticsearch from that particular library, and then I started initializing this particular client using this particular code. So what is this cloud ID, and what is this API key that I'm using here? So as I spoke previously, like the entire cluster is in cloud, and then I have a specific identifier to identify this cluster. Otherwise, you could use a URL in terms of cloud ID, and then like give localhost 9200 or something else. I also have an API key instead of a username password. Probably if you are a long-term Elasticsearch user, you might really not understand why I'm using API key, why not username password. API key is relatively a bit new feature. Again, I would recommend you to go and take a look at it. the current information, these are the information that is being picked up from a specific config file that I have here, which we need to configure right now. So it looks like I already have, but no, I didn't create. And then let us create an API key and use the latest uh, uh, the details actually. So let us create PyCharm, and then I don't want to restrict privileges, but I just want to, like, give 7 days as the expiry time, and then I used to create API key, and then this would create an API key that is there. It shows different versions, and then I would recommend you to go and look at the beats, the JSON version. And of course, like, a lot of these are also, some of them are preview features, and then, like, please take a look at it, and like use it carefully when you are trying to use it. So that's something that I want to like tell you. So I'm going to use the ID here and the secret. Okay, something wrong. So as I said, like, I have a cloud ID, which is nothing but a base 64 version of the, like, the Elasticsearch identified, the cluster ID, etc. So I'm gonna use that here. So having this in a config file is much better than writing this in the code. So if you have much better way to do, or if you have a org standard way to invoke this, that is much better to go and look at this. So I also have loaded this config file into into JSON structure, and then I'm referring that to initialize the client here as ES Elasticsearch. Let us go and look at the basic endpoint, and then we can come back and talk more about the search, etc., and then, like, probably modify and change and do look at more things. So I have basically what I have here is, like, I have created a search query which says, like, say query match all. And what is this match all query? I'll tell you about that, but I'm just using that client to search over my data. And if it returns some data, I'm gonna give out my index.html. So index.html is there in my templates file, and that is where I have this entire the page, that entire page that I showed, which is also written in the Tailwind CSS. So that it's a simple HTML with some text classes, etc. So let me stop this particular screen. I don't know why the configuration is missing, but I think this is the one that I need to use. I don't know why it is not working. Anyway, so let us try to run with this one and then see if it works. If it's not, then probably we'll see the error, and then we'll probably debug that. So as you could see, there are some error. It says, like, file not found, config.error. So I have seen this error come up sometime before, and I just use the Flask integration here to probably use that script, and say choose the script. Okay, main.py. So I'm just setting up a Flask server, and that's for development, interpreter and everything. Nothing more than that. Simple. So I just have this. Let us try to run this one with this one, and then I see that the app is up and running. So if I run probably with a Python space main.py, everything, it might work because I'm running it simply with the interpreter, and I mean from the terminal. But because I'm running with the IDE, there are some more things that I might need to do, and then I'm just using again Flask to an integration that is already there in the IDE to do that. So over to the page, and let us quickly go to the local host and see if I have got the page or internal server error. So okay, again, I'm not really good at the UIs. I don't know why it has come here. It should come in the center, but then maybe it's like, different. So I have this particular page where it shows this is a simple index.html, and then I have search here, and then and search bar, and then, like, it says that configure your cluster credentials in config.json and index data by calling index.endpoint. Why did it say this? Because I think even though we have configured the config.json here, but then we kind of like we kind of couldn't like do a have the index movies, and it might be generating an exception. That's why we do it. I could remove this and show you the error as well. So that is one another way to look at things. We could try doing that. Let me see if we could do that and see what error it returns, so that way like you also know what is wrong. So let me remove this. We could spend some time here because I think it's important that we learn about some of these details, and better understand what's happening in the API. Restart the app. Okay, let me do this once again. So we should see an error if not this time. So what I'm doing is like it's saying that index not found exception, that there is no such index movies. That means it made a connection, but it is not. I could do more granular exception handling, but I just chose to just do as Elasticsearch exception by importing the Elasticsearch exception. You already see that it is not used as in the API. So let me quickly go back and enable the code that I have. So as you could see that I'm just doing this just to make sure that we don't run into errors on the fly. And there are much better ways to handle all of this. And like just because it's a sample app, I'm just using that. So when there is an index, and then you would be able to see some data, and you would be able to go through it. So first of all, let us try to understand how do you index the data. And there's a key in doing that actually. So there is a specialty in ingesting data into Elasticsearch. Now, usually if you want to ingest data into Elasticsearch, what you could do is like go to Kibana or call some API, and then probably kind of like do probably do like post API, or run another solution to kind of like Logstash to pull data from a different source. So there are a wide variety of ways using APIs, using a client like some programming language like Python or Logstash or Beats, whatever. But there is a catch there. If you are using some standard ways, you would potentially use the bulk API, which is essentially the API that helps you to ingest the data. Like say usually you type the data like this, like you say doc is the doc type, and you say like and then you start ingesting name Aravind, and blah blah blah, and so you do that. This is how you ingest the data, but this is one by one doc ingesting, and it might take more time because it goes through the entire stack, and request response stack, and it will take more time. So there is also another way to do this thing. Like suppose if you want to ingest the data by bulk, there is a bulk endpoint which helps you to ingest a lot of data in single point of time, and that is more beneficial and useful if you are using a client, and then you want to push data, even though it is some sort of 500 documents always recommended, not so much, but then always recommend you to go through that. So here I also have an index endpoint. As you see, it is trying to open movies.json. I'll see if I could open that because it's a relatively large file with 5,000 movies in place, and then I have a lot of movies here, and then I just try to ingest that into Elasticsearch. So let me try to do that, and run the app and try to do that, because we already have the app running and we could do that. So the code just says that we are just reading this file, and then making a dict, and then using helpers.bulk, which is the bulk API that I spoke about, and then using the client, and then ingest the data into documents. All of this is coming from the standard, the ES client, and I have also imported the helpers. So we covered three things already. So that is not a you should be able to understand. And if you have questions, I'll stop after this thing, and we'll see if you have any questions to ask. So let us quick to see if our thing is back. It's not. So let me restart the app so that we have the exception handling code in place. Then it's back. And then now I am just trying to run the index endpoint, and then I'm simply clicking on end, and then it should ingest the data and show me the things. So I have a sample app. This page is not designed, so that's why it shows very simply. But you see that there are 5,000 documents that are ingested, and I have put that in the about page, and that's what you are seeing as a data, and that is presented. So that's it about the ingestion. Let us go to the Kibana and see what's up with the data and how it got ingested, etc. So I could go to get movies, and like just say, so I could go and do count, and it should see 500 documents ingested. As you see that this index was previously not there, just started ingested now. I should have shown that as well. So we'll see also mapping, what mapping it took, because we didn't do any explicit mapping. Whatever the data it ingested, it did dynamically ingest the data. So let us quickly run this. So if you have doubts about how I'm running this, like the API, I'm just doing command enter, but there's a play button here. You could do that as well. So now, like when I run this API, it shows me all the mappings that are there, like how each how each field is mapped. You also see that keyword every time, so which is not the best again, because you might not want to search everything as is as a term. Elasticsearch has different data types, just like any other programming language or a database. Like you have in like say MySQL and all, you have varchars, all the regular SQL data types, or more data types that are more specialized to the databases. No, Elasticsearch also has similar data types. There are many data types which are very specific to your use case, your query. Say for example, if you want to do autocomplete, you could use a different type of data type, like say suggester or best fields, cross fields. There are different fields actually, different types of field types. And then like you also have different ways to generate that field type on the fly as well. It's called runtime field. So you could do all of that. So sometimes you might want to, like say for example, there is year in this particular the data, which is mapped as long, but year is not a long, right? It's a number. So you could very well create all of this like in just one document, see how your mapping is decided, and make it much better. What Elasticsearch does is like makes it better for your use case, and tries to just generalize and give some random stuff. But then like you are the owner, and I would recommend you to do this exercise by yourself. So long story short, like I'll just go and show the document, and I'll see if I could take some questions from you. I know I've been talking about for long, and then let us simply, okay, let me show you a search and then see how the data is. So if I go and do a simple search, empty search, I didn't have any body here. As you could see, it shows the hits, like how many number of hits, and then it shows max score 1.0 because it's a simple all bring all query kind of thing. And it shows all the documents that are there. Of course it has a size limitation. It doesn't build everything, but then it has a size limitation. What I'm also going to show you is like match all query, which is a query that's like the select star. So say match all, and then it simply matches everything. And then, like I said, it's a simple select star. So with or without doesn't matter. If you want more specific queries, you could go and do that. So all of this is available. Again, these APIs are implemented in the Python client, and then you could use this query that you are trying to find the data, and you copy it all in the client like this, like what we have done here. And then like you'll be able to see that. See, for example, if I miss a simple brace there, I might not be able to show this demo, and then we might spend a lot of time doing all of that. So any questions? So I am happy to answer at this point of time. No questions, I think.
I have a pretty simple one. So, taking a look at the millisecond responses of Elastic, it's like 117 milliseconds, and you get everything serialized really fast. Can you just, tell me how does that work compared to a regular database like Postgres? How is Elastic able to give you such quick responses?
So basically, like I said, Elasticsearch is a distributed NoSQL search engine, and it uses an inbuilt library called Lucene, which is a full text jar. And but then it's a jar, like that's the catch, right? It's a library, just like any other Python package that we use. And but it should not be a only thing, that helps you to do all of the search related stuff basically. But then it is not useful for other language developers. So what Elastic has done, or Shai Bannon, who's the creator of Elasticsearch, what he has done is like he used this library and built a distributed data system, which is Elasticsearch. But if you got to know the entire story, there is another prequel to Elasticsearch, which is called Compass. It's not distributed, but it uses the same terminology, but it's a single server, which kind of like has this library. And what it does is like stores all the data in a specific search specific data structures internally, which is also called as segments. And then when you fire a search query using the REST API, internally it converts that into Lucene query, and then that Lucene query gets fired on all the segments which are present across the nodes, and then like gives you that result in milliseconds response, because it's parallelly getting executed, because it's horizontally scalable. It's not a vertically scalable system, but it's a horizontally scalable, and then that's why uh, you see all of that. But of course, there are a lot of ifs and buts, and when you reach the scale, I would definitely recommend you to anyone to like kind of take a look at your hardwares, your mappings, which is very important. So all of this comes into play when you're talking to like massive data. But initially it can give you millisecond response and might amaze you very well. It's the long
Wow,
answer.
that's
So
amazing.
Lucene,
So yeah,
yeah. So Lucene, I want to add, like Lucene. Initially, I was a Java developer, and I spent a lot of time in Java. And then initially, when I started looking at Lucene, it really felt that it's quite easy to use Lucene in my in my any Java app, but it's also hard to use Lucene as is. And then I realized that when I switched into different programming language, how difficult it is to use some other tool to like just manage all of this. And then Elasticsearch helps you to do all of this pretty easily, and it might look easy at some point as well. So that is the catch here.
awesome.
Yeah, yeah. So let me go back, and I think if there are any questions I'm going to answer, I specifically don't see, but please feel free to stop me in a field, and then I'm happy to answer as many as questions. So let me go back to the page, and then see, I like I said, I showed you Kibana, and then I showed you the query match all response, which gave me everything. So if I kind of like now go back to the home page, I should be able to see all the data in a similar format, because I'm just trying to do a get of simple slash, and then it's running a query whatever we ran just now, and it doesn't generate because there is a movies index already. And then I'm just iterating over it, making a movie list, and then sending it to index.html, and I'm using a template to like simply run over and create an experience. So I'm also using a sample image here, because somehow the IMDb image that I have is giving a 404, and then I might not have the right API key or something. So I'm just using a sample image. Otherwise, you would see different posters for different data. So let me quickly go back and see if I could see that. Uh, there you go. You see that there is a search bar, and then there is a data, and then you see this forward. Somehow this particular data point doesn't have a summary. So so whatever works, right? So all of this is happening now. Let us go and talk about the real search. All this is great. I just ran a simple search query. I just showed you a search endpoint. But how about running a simple, running something more interesting? Like I said, you have this, I have a search endpoint here, and then I'm just trying to get the form value here, and then and just trying to run a search query, a multi-match query on top of the data that I have. Same logic again, nothing different. So what is a multi-match query, and how does it really work? So let us take this query part here. I know you might find I feel that this copying and then this putting this JSON structure into the code is probably a bit weird, and then I don't might want not want to do it. I have a solution to that. I'll come back to that as well. So let me search, and then I think we are good this way. I hope it has the right number of braces. Let me bring that up so that it's not so difficult. So this also does some sort of a cross-checking, so that if you have more braces or if you have some problems, it should potentially work. So I don't know why it's not working. Maybe let us see if it works. Uh, so yeah, the something is wrong here. Okay. Okay, the query is wrong. I'm really bad. So basically, you could type like, okay, let us do iron. So if I have a bunch of movies, like 5,000 movies which are from IMDb, and I want to like kind of, as you see here, I have, let us take a look at one document, like say for example, like this document, like it has directors, title is traffic, it has a plot, and it has actors, the image URL, rank, like runtime, rating, everything, right? And I just did a select star kind of a query, which is match all. And now I want to go a bit more deeper and like search for a full text on title and plot, because both of them are full text and both can kind of like do much specialized stuff. So I'm gonna run this and see what results that I get. So previously when we did a query, it's just max score is 10. That's like what this specific score will do. I'll tell you in a minute. But then you see there are 5,000 documents and score is 1.0 and it lists everything. But when we do this, what Elasticsearch does is it says that it got 9 hits, and I mean nine. It got 9 hits, and then max score is like something, like 6 dot something something, and then you have all of these hits here. And obviously the first one is the Iron Man, because the word starts in the first place, and then it has the right way that we want to do. You also see the case doesn't matter anymore. You can make it happen, like if you want case as well, but then as and when it kind of like goes forward, it'll show more and more. So how does this ranking happen? That's the key thing, right? Even search engines like Google. So the relevancy is the thing that helps you to do all of this. So for example, there is a max score that is given to this particular query, like a specific document which has got the biggest amount of score, which is the first one. This is the relevancy score. Like it calculates, it puts this query onto these fields, just thinking in a very blunt manner, and then it finds all the documents, sums it up, and then ranks it. And then that ranking is done through an algorithm previously called as TF-IDF. You might have heard of it. It's like term frequency by inversion, document frequency. It kind of find out how many times this term has repeated in the entire corpus of text, whatever I have given, like multiple fields here. I could also make only one field, but then I chose multiple fields, and then that is the term frequency, like how many times a term has repeated in a corpus. And then like I also have the inverse document frequency, like how many times this term has repeated in the entire data set. Like I will go and see how much times that iron in the title, iron in the plot has repeated. That gets a specific kind of like value, the numeric value. It also calculates several document distance, etc. And then like I'll also get how many times this iron has come up in the entire data set, how relevant it is, and it calculates a score based on it. That score is the score that is given to each document, and that document ranking happens based on that. Of course, and whatever I spoke is very naive and simple. There are much more things that happen. Like right now we are using something called BM25, which is a different sort of algorithm which does still use TF-IDF, but it also adds some more information, like more better document distancing up to 2 or 3 words or letters. There are more tuning that you could do specific to it. Now you could understand like how deep we are getting into this search related thing. It might also become complex if I start talking more about other topics. That's why we are trying to limit it to some extent as well. So now I have the search bar, and then like I have this hits going on. So let us go and quickly search through our app through the same thing and see how it works. Like, so I have iron, and like if you see, same details that we are getting, but in a different manner. Like I'm just presenting it much better and using the tailwind and everything. Now that being said, let us go, like I said, let's go and talk about the query part itself. Like you see that all this is great, but then it lacks some sort, it has a verbosity as well. It is queries and it puts everything into this place, so it's difficult, right? So what Elasticsearch has done is like this particular this particular the particular structure of the JSON is called query DSL, which is query domain specific language. Like it's like a SQL, like how you learn SQL, like select commands, insert command, all of the commands that you learn. Similarly, Elasticsearch has its own query DSL, a specific language to interact with the APIs and talk and ask questions so that you would get results. So query DSL is like it has a learning curve, I do agree, but it's quite useful when you start doing more and more stuff on Elasticsearch. But then like in a code, sometimes putting all this JSON, and when you have more queries, like say for example, this is a simple query, you might have like a bool query, like something you have multiple terms and you want to do match this but exclude that, and it should be in this year, and it has this sort of a boost, etc. You talk more about more blocks, then this becomes a this level a very long JSON, and then that might be a problem for you. So that's why we have Elasticsearch DSL, which is a Pythonic library, which is on top of the Elasticsearch server, and it implements all these things, and then it helps you to write much better code, easier code actually. So I don't have this implemented on the on the on the data side, but I have on the UI side. I just have this a different endpoint like search hyphen DSL. I could fire this. It's not a post command. You see, it's a get command. So, but the same command I could run in a much easier fashion. I could run the query part using ES index same, and I could also go and do like dot aggs and fire an aggregation, or go and do more stuff like uh, summate all these queries and then execute at a one point, but much better readability, and you could also learn and do these things much easier. So all of this data is already available on the read the docs place, and then you could go and go through all of this API documentation much easier. Again, let me show you. It's not so different, but I'll just in the code only you see the difference, but then you might not be able to change that. So let me see the item. So and see, because I'm doing match, not match all, not multi-match, on only title, not multiple fields. There might be a difference in a bit of the details, but then it doesn't matter. So also, if I restart the app, it doesn't have any effect on the data store. It's pretty simple and easier to go through and look at things. See, it's not so different, but then you write better code. So that is one another library that to look at. So we spoke about both of them in here. But this is great. Elasticsearch is cool, and then I could go on talk about other APIs, other queries, go on talk about mappings, etc. Now, well, all this is really great, but you also see that the complexity for writing a simple app or simple query, you might see that okay, I need to learn. There's a bit of learning curve to use Elasticsearch. You might have that feeling. So that's where I started to appreciate the feeling that for better developer experience, there is another way that you could go through and achieve the same, but also use the Elasticsearch as well. So let me go and show you the app search. Let us move to like say a different branch, and then talk about that. I have few more branches, but I think this one might not take some more time, and also try to talk about more of the stuff. So I'll just do force checkout again, discard my changes. Let us go and look at it. Same structure, all the same. I should have retained the Elasticsearch is still there, but you need to configure a different server details here, which is a layer on top of Elasticsearch. You might not need this because we are not reading. You might just skip this one. This is not needed, but you need to configure this particular thing. Now, like I said, app search is a layer on top of it, which helps you to manage your search experience much better, which I'm going to talk about in a minute. But then like this is how you could do that. All other things which are very similar, the code, the way that we ingest the data, everything is similar, but then I'll show you how different it looks like. So let us go back and copy this search this particular URL of this instance. Again, you could run it on your laptop. All that you need is like Elasticsearch. On top of it, you run this particular enterprise search instance, and then again it shows API key. What is that? Let's go and see the app search experience one. Now all of these APIs are getting executed on Elasticsearch. Now I'll show you the app search. App search is there in the left menu as well, but if you want to search here, you will go and look at that. So this is a layer on top of it, and then you could create a search engine by clicking on create search engine, and but that also we'll try to do with the client that is there already, and then we'll not use this particular experience, and then show how to ingest the data. What is the special details with this? I hope we are doing okay with the time. I'm thinking that we are late, but then I'll try to complete it and show you more details in a few minutes. So I have a API key, which is this. So there are some standard API keys. You could also create more, as you could see. And then I have the engine name file. I'm trying to create similar sort of engine. You see that I'm using the same cluster, to do all of this. It doesn't really change anything. But if you're using for production, don't do this. Like don't use the same Elasticsearch cluster for search or your other use case. Like try to remove search use case as separate and use it for a different use case. Just for in the interest of demo, I'm trying to do all of this. So it's simple. Again, the same Python app, config.json, start running it. I hope it runs. No, it says config.json is not there. Then I think, I don't know why it has gone. Maybe I didn't configure this much better. Okay, I clicked it. Yes. So yeah, so I just have this one running. So let me see. Okay, so it's ready. So it's the same experience. It doesn't really change much. The same app. So I don't know why this one is done. It says like could not find the engine, right? How really bad, right? I should try to find the engine first. So what we need to do is like fire the index API. It reads the data.json, slightly different data because I want to show you something more, like the posters and all. So I just chose the other JSON. It's also a movie database, but probably more regional. It's Indian movies, Bollywood. And then I have the documents loaded and redirects to abba.html, all same. But if you see, we are using a different client here. We are using Elastic Enterprise package, under which I'm pulling out app search client. And then I have initialized the client with here. And then I have configured the engine name, whatever the engine name I have given. I'm just firing out like, create when I'm trying to create index and then create this index documents, etc. So I'm trying to do that. So let me go and show you the index, and it will index the documents that are there. I don't know, even this is giving an error. No. Okay, let me
Hey,
see.
Arvind,
Oh, okay.
we're a
Yeah,
little bit over time. So how about we answer a few questions that people have?
definitely. Definitely,
Okay,
definitely. That's what I.
so
Okay, sure.
this was really about databases coexisting with Elasticsearch. Just wanted to ask. This was asked by Vlad Besden. You said yes, users have their own databases. How does data go from databases to Elasticsearch? In other words, what is the best way to push your data from a database like Postgres or MySQL or or Microsoft SQL Server into something like Elastic?
Okay, so like I said, all of these databases have their own indexes, but it might not really suit your use case, etc. So what essentially I would recommend you to like do is like you add Elastic as a speed layer, and then if you want to move the data, you should definitely use a syncer in between. Like it might be different use cases. So how do you use this sync? So you use Logstash as a syncer, which is like a ETL. So it can extract data from your database. Filter out or modify it or structure it in a JSON document that you want, which is the filter part or the transform part, and then you load it to Elasticsearch in an index that you want to provide a search bar upon which you are trying to search. So that is how it really happens. So obviously you don't expose the Elasticsearch index directly to the users. You would have a proxy or like an application in between that interacts with Elasticsearch, firing all the queries through your front end. So that's what happens. So what do you use in Logstash to try to connect to any RDBMS? There is a plugin called Logstash JDBC input plugin. It goes by the same name, Logstash JDBC input plugin. So this is a plugin that you kind of like configure your JDBC driver details of your database. I guess all the databases have JDBC, and you kind of like give your query, like say whatever the data that you want to pull from a specific view or a table, and let it run, and then it keeps syncing. So now if you want to do, like say if you have a table with a million rows coming every day, and you want to run it at a specific place, you could also do all of that data pipelining thing. You could also, Logstash also has a queuing facility which you could use as well to handle the back pressure and etc. One more suggestion that I would give you at this point of time, if you want to do incremental fetch on your table, like say fire a query, you get a bunch of like a million rows, and then you ingest the data into Elasticsearch, and then your pointer stays at the million. So every day you don't scan the table from the first, you scan from the million and one row. From the next day or the next minute, whenever the new data comes up, it starts firing the query and like does that incremental fetch. So that way you could ingest the data. So that is one good way to do it. But then I would always prefer using the clients of whatever the programming language that you use, because that's the best. you're just sending it to two different agents. It's real time. It's much better rather than you write in a table, use a syncer, you're running an infrastructure separately, an engine or like someplace, and then you need to monitor that, manage that. If it fails, you need to restart that. So think about
Yeah.
all of that maintenance.
So
Otherwise,
so it's
just
better
use
it's
that.
better to just use something like a managed log stash that is going to sync all this stuff for you and pump it into Elastic.
Yeah, I mean,
So s-
there is nothing
so
like managed log stash. Suggest you
oh,
to use the client. Yeah.
there's
Yeah,
none
yeah.
of
There
that.
is managed log stash. Elastic doesn't do the managed log stash. You could use ingest pipelines if you want to transform the data. It's another pipelining API actually. Yeah.
Got it. Got it. So one person asked about the way that you push data from multiple microservices is to Elastic is using beans. I'm not that familiar with beans. Are you? Is
Okay.
it a
So okay, okay. So beans, not definitely. I think it's probably a typo. It's called beats. So there is
okay.
different types of beats. Beats, libbeat is a Golang based package upon which there are multiple beats that I have developed, like file beat, metric beat, audit beat, packet beat, heartbeat. Each beat does a specific functionality. So you would probably use my file beat, and then to ship the logs. Actually, we have a branch in the same code. Like you could go to the add APM logs, and then I'm just running a Gunicon app, and then you could use the beats to pull to take that particular log file and ship it to Elasticsearch. So that can be done as well.
Okay, wow, that's I didn't know that. I would just my invention for working with Elastic was just to use listen/notify on Postgres and also just pipe all the log files directly via API.
There are
But
different
I'm
ways, and then yeah,
but I'm
people
glad
use
that
it
works.
differently.
So that's all the time we have for today, Arvind. Thank you so much for joining us and giving us a real rundown on how things work with Elasticsearch. Thank you very much.
Cool. Thank you.